get to chemistry, you may do that. But for right now, all you need to be concerned with is if you have a metal and a non-metal, it's ionic. Something from the left side, something from the right side, it's ionic. We'll get to the other stuff later. Let's just understand one at a time. Okay, Zach?
If you have like a sink and like a water, and you get water out of it and like the metal from...
No.
Is that
No. No. That's something different. That's
What if you have two non-metals?
We'll get to that tomorrow. Okay? All right, let's look at some more examples of ionic compounds, okay? Let's look at lithium and fluorine. First thing you always have to do, so lithium and fluorine, the first thing you're always going to do is give me the valence electrons. Draw the Lewis dot diagram. How many valence electrons does lithium have?
3.
It has 3 total. How many valence electrons does it have? What column of the periodic table? 1. It's in the first column. It's in the first column, so it has 1 dot. What about fluorine?
7.
7. So I'm going to draw 7 dots. How many does fluorine want to have?
He don't want to have...
He wants to have 8. Wants to have 8. Everything except hydrogen and helium want 8. Okay? So what is it going to do?
It's going to borrow.
Borrow? No.
He's going to take it.
Take. From where?
Lithium.
Lithium. So he's going to take this from lithium, or lithium's going to give it up. Going to give it to fluorine. If lithium gives up an electron, what charge does it have?
A positive.
Positive. It's giving away negatives, making it more positive. Fluorine is going to be what charge?
Negative.
Negative, because it's gaining negative charge. Okay? So this is an ionic compound. How do we know it's ionic?
Because it has 2 different charges.
It has opposite charges. What's the other way I can know?
One's metal and one's non-metal.
Which one is which?
Lithium is metal and fluorine's non-metal.
How do you know lithium is a metal?
Because lithium's on the left side.
Left side of the periodic table. Fluorine is a non-metal. How do you know it's a non-metal?
Because it's on the right side.
Right side of the periodic table. Very good. Okay? Making a little more sense now?
This what our test is on?
No, sir.
Oh,
Okay. Let's do another example. Let's look at something that you are actually pretty familiar with. Same way. We're going to start the same way. So what's the first thing I'm going to do?
We're going to see how many,
What do we call that?
electrons.
What kind? What? Yes, we need to see how many electrons it has, but not total electrons. I'm only concerned with the what?
Ones that he wants to like get rid of.
Which we call the what electrons? Starts with a V?
I don't know.
Valence.
Valence.
Valence electrons are the only ones we are ever concerned with. They're the only ones that do anything in a reaction. Those are the valence electrons. So how many valence electrons does sodium have?
11.
No, that's total electrons. How many valence does it have?
I have 1.
1. It's in the first column of the periodic table, it has 1. What about chlorine?
7.
Because it's in the 7th column, it has 7 valence electrons. So, what's going to happen? He's going to take that 1 from sodium. That means sodium will have a what charge? Positive 1. Chlorine will have a negative 1. We made an ionic compound, sodium chloride, otherwise to you known as table salt. What you sprinkle on your food. Sodium chloride. Now, we specifically say table salt because this is the only one that we really eat. Any ionic compound is called a salt. Okay? Anything that has opposite charges, that's metals and nonmetals is also called a salt. It's just another name for ionic. We call sodium chloride table salt because that's the one we eat. We can't eat all salts. We only eat table salt. Okay? So, I think there's sea salt that's in the grocery store. If you can't have, trying to watch your sodium, you eat sea salt, and that's potassium chloride instead of sodium chloride, or something else like that. But any ionic compound is called a salt. Okay? All right, let's try. Now, let's do this one. We haven't done one that has two things in it before, but let's just start the same way we start all of them. So what are we going to do first?
Find out the
I don't know what they're called.
You need to know what they're called. Valence electrons. Very good. How many valence electrons does magnesium have?
2,
2. How many valence electrons does chlorine have?
7.
Each one has 7.
What?
Okay, I got 2 chlorines. That's what that 2 in their set means. That 2 out front. Oh, I can't erase it either. It means that I have 2 chlorines. So there's 7 electrons around each one. So magnesium wants to get rid of 2, but chlorine only wants 1. So what do you think is going to happen?
One chlorine's going to get one, take one, and then the other chlorine's going to take the other.
Very good. Very good.
Smart thing.
So what's going to happen is 1 electron is going to go to that chlorine. 1 electron is going to this chlorine. So we have magnesium with a +2 charge, chlorine, and how many do I have?
1.
How many chlorines do I have?
2.
I have 2 of them. So I put that little bitty subscript 2 to tell me that there are 2 chlorines. And each one has a -2 charge.
Why does magnesium, or whatever it is, have
+2 because it gave away 2 electrons. And it's one of those where it will not give away just 1. That will not give it its 8 that it wants. It's going to give away 2, or it's not going to do anything at all.
So is chlorine going to have -2?
Both of these together would be -2. Yes, ma'am. Zach? In just a minute. Okay, so that's it for our examples. We're going to do our data set question now, and then we'll be done for today.